For example 7, we are going to be solving a rational equation that first requires some factoring. That's what you'll always want to do before jumping in there and figuring out what's the least common multiple, because to figure out the multiples you have to know the factors. To know the factors you have to factor. And so for this first term, I'm going to rewrite this as 4 over x squared minus 2x minus 8. As you reviewed section R.5, you reviewed this factoring, and I also like to call this type of factoring unfoiling. Okay, so if we want to unfoil x squared minus 2x minus 8, remember we look for the two numbers that multiply together to give us a negative 8, but then combine together to give us a negative 2. And so that is going to be a negative 4 and a positive 2. And that is how we would unfoil x squared minus 2x minus 8. Now, if we wanted to quickly check that, which you won't multiply this back through, but you will mentally check this, you would then FOIL it out. X times x is x squared. Outer times outer is a positive 2x. Inner times inner is a negative 4x. And last times last is negative 8. Then when you combine these terms, you will have 2x minus 4x is a negative 2x. So x squared minus 2x minus 8, that is exactly what we have up here. Therefore, that is how that would FOIL. Okay? Let me erase that. Now we're going to go factor the other terms in our equation where necessary. In this next term, leave the numerator a 1. The denominator is a difference of 2 squares. And recall the difference of 2 squares is x plus 4 in this case multiplied by x minus 4. You could check that out by FOILing. First times first is x squared, boom. Outer times outer is a negative 4x. When we combine that with inner times inner of a positive 4x, that gives us 0x, right? 0x. Last times last is the negative 16. Next, bring down the 2, and then the denominator of this side is also a unfoil, you know. These quadratic trinomials a lot of times factor into two binomials. Once again, remember to find the two numbers that multiply to give us positive 8, but that this time add or combine together to give us the 6. And that would be a positive 4 and a positive 2. Okay? Now that we have the factored form of our problem, we want to go through and find restrictions on our variable. Our values for x better not consist of a positive 4 would make this factor be 0, therefore that whole denominator is 0. So we're going to restrict a positive 4, a negative 2, okay, oh, x can't be equal to these, okay. We're going to restrict a negative 4 and a positive 4. Okay, I'm going to put the negative 4 up here. Positive 4 is already written there. Here, what would make this factor be 0? Therefore, giving us 0 for that whole denominator would be a negative 4. I've already got that above. And also a negative 2. I already have that. So these are the values that I better make sure are not in my solution set. If so, I would toss those out. The next thing we're going to do is figure out what is the least common denominator here, okay? Basically, what all factors do we need to get these canceled out? Well, we need a factor of quantity x minus 4 to be able to reduce that first factor. We need a quantity of x plus 2. We need a quantity of x plus 4, which is totally different from x minus 4. We need an x minus 4, we already have an x minus 4. That's going to reduce for us here. We need an x plus 4. Got it. We need an x plus 2. Got it. So these three things multiplied together are going to be our least common denominator. However, the good news is you don't have to multiply those together. What you do want to do is go through here and multiply each of these three terms by x minus 4 times x plus 2 times x plus 4 everywhere. Okay? So instead of trying to attempt to write that out 3 different times, that's enough of a mess the way it is. With my smartboard, I have the ability to clone and clone again and then move them over where I want them to be. Doesn't that kind of make you mad that I can do that? But I can. And so you do, though, with your pretty handwriting, you want to be able to recopy all of those, multiply. Okay, now comes the fun part where we get to wipe out the common factors and write what's left. This x minus 4 reduces with this x minus 4. Well, it's not wanting to mark over that for some reason, leaving us with 1s. Okay, the x plus 2 reduces with this x plus 2. That's so weird. Okay, leaving us with 1s. So what we have remaining is the 4 from right here multiplied by the quantity x plus 4. Bring down the minus sign here. Now jump over to the next term and reduce your common factors. The x plus 4s fall out. The x minus 4s fall out. Okay, leaving us with a minus 1. If you want to write that 1, that's not a bad idea. Multiplied by the quantity x plus 2. Okay, now here we can reduce the common factors of x plus 4 and x plus 2. Leaving us on the right-hand side of our equation with 2 times the quantity x minus 4. All right, let's finish solving this up, and let's make sure that we don't get any of these values for our answer. If so, we'll toss them out. For this first set of parentheses over here, we're going to multiply the 4 through, so we'll have 4x plus 16. Here we've got to distribute the negative through, so that's going to give us a negative x minus 2. And then running the 2 through, 2 times x is 2x, then 2 times a negative 4 is negative 8. Combining like terms, 4x minus x combined to give us 3x. 16 minus 2 is a positive 14. Bring down that right-hand side. Subtract 2x from both sides to move our variable terms to the left-hand side. That means we're going to move our constant terms to the right-hand side by subtracting 14 from both sides. Okay, so that gives us 3x minus 2x is 1x. That's going to be equal to a negative 22, which is not any of these bad values above. So we can circle that up or put it in our solution set. Done.